Hi class, this is your instructor Megan, and in this video I want to talk about collaborative and collective intelligence. They are two different concepts. We're going to start by talking about collaborative intelligence. And I really don't want to go over the reading. I think the reading's pretty self-explanatory. What I want to do is give some context to the reading. So Reingold writes quite a bit about collaborative intelligence, and he writes quite a bit about how to be a good cooperator and how to participate in collaborative groups in order to create collaborative intelligence. And Reingold suggests what he calls a tit-for-tat strategy. And I want to give you some background on that so that you understand where that term comes from. What does it mean, a tit-for-tat strategy? He just sort of casually writes, you should use tit-for-tat. This term is not some gibberish that he's just made up. It actually comes from a famous experiment, which I want you to learn more about. So there's two videos about this experiment where the term tit-for-tat arises from, and I want you to watch them. The first is 8 minutes and the second is 10 minutes, so they're not super long. The first one is available here, and the second one is available here. So I want you just to take a minute to, take 18 minutes to watch those videos. It's really important that you do watch them in order, that you watch part 2 of 5 here first, and then part 4 of 5 here first. We're going to skip 3 of 5. And just take a minute to watch those. So I'll just wait a second. I assume if you're continuing to watch that you've watched the videos. If you haven't watched the videos at this point, then what I'm about to say is not really going to make sense to you, but I just want to give sort of a wrap-up of what you learned in the videos. So you obviously have seen in these videos where the term tit-for-tat comes from. It's the name of the program that did exceptionally well when put into a prisoner's dilemma type situation with other programs. So tit-for-tat is the strategy that was used by the most successful program. And we can learn from this experiment how to be good collaborators. So tit-for-tat can be sort of a role model for us as we try to work collaboratively online, and that's why Reingold suggests that we use a tit-for-tat strategy. So what are some key qualities of tit-for-tat that we can use ourselves when we're working collaboratively online? Well, first of all, tit-for-tat is nice. Dawkins describes tit-for-tat as nice. And what that means is that tit-for-tat extends goodwill. So when you're collaborating online, when you're joining a group of people who are trying to solve a problem or make a decision or create something, the first thing you want to do is extend goodwill. So you want to be nice to begin with. You can't go in assuming that everyone is dumb or they're not going to help you. You have to go in and extend goodwill and let people know you're willing to participate, and just give them the benefit of the doubt that they're going to participate back and be good collaborators. Tit-for-tat is not envious. So tit-for-tat actually doesn't win against individual opponents because it just copies what the other program does. So you can use this as you collaborate online by just trying not to one-up other people. When you're working with other people online, it's not a contest to see, who's the smartest or who gets the most done. That's not how it works in collaborative groups. When you go in and you're willing to work with other people and you don't see them as competition and you're not constantly trying to one-up them or pull something over on them or, defeat them in some way, then you are better at cooperating in those groups, which means the end result of what the group makes, the intelligence that arises from the group, is going to be better overall. And finally, tit-for-tat uses a forgiving strategy. So if someone doesn't cooperate, you just don't cooperate back. If they're not cooperating, don't give them anything to do. Just kind of ignore them. If they come back and they show that they can cooperate again, they come back and they start contributing, then forgive them and accept their contributions and bring them back into the collaboration. So what this means for you guys as you work online is you want to extend goodwill. You want to not see your work online as a competition, and you want to forgive others in the group and give them space to kind of get that forgiveness. So those of you who want to go on to work in social media, when you create those architectures of participation, you want to foster this kind of architecture. You want to foster an environment where people will extend goodwill to each other, where you trust the people you're asking to participate initially. You want to create an environment where it's very collaborative and team-based and it's not a competition. Unless you're creating a game or something like that. But you want to create a space where there's rules, but the rules are forgiving. They're not punitive rules. And Reingold talks about this as well. You don't want to create an architectural participation where if you screw up, you like get immediately banned. You want to create an architectural participation where you do tit for tat, where if people don't contribute, you sort of don't accept their contributions. But then if they show that they're trustworthy again, you let them come back. So that's what I wanted to say about collaborative intelligence, but I want to talk about collective intelligence too, because it's a little bit of a different concept. And from the idea of collective intelligence arises this concept called wisdom of crowds, which I want to talk about also. So collaborative intelligence is people working together, and they're explicitly working together, and they're having to be part of a team. They're having to use the tit for tat strategy. In collective intelligence, we have aspects of that, but this term more refers to the hive mind, an intelligence that arises from a group that doesn't necessarily directly work with each other, directly interact with each other. Typically, their interactions are facilitated through technology, and they're not happening in a collaborative environment. They're all doing their own thing. Technology is bringing it together and creating a repository of everybody's thoughts and ideas. So Wikipedia is a really great example of collective intelligence. People contribute what they can, whether it's an entire article, fixing a spelling error, adding or editing a section, or even just flagging issues with a page. People just contribute what they can, but they're not working collaboratively. It's not like the Wikipedia editors get together and consult each other on how they're going to edit and what they're going to do. Everyone just does their thing on their own time. And the technology, the architectural participation that has been built around Wikipedia involves this technology that sort of keeps track of what everyone's doing. And so you can see what other people are doing. If they've done something wrong, you can fix it, but you're never really collaborating as a group. You just come together as a group. The technology allows you to work like a group without actually sitting down and talking to each other. And so a similar concept to this is wisdom of crowds. This is the idea that collective intelligence is used to make decisions or solve problems, and when it is used to make decisions or solve problems, the end decision or the result or the solution is often smarter and more accurate than any one contributor's suggestion. So James Surowiecki wrote an entire book called Wisdom of Crowds. It's great. If you're interested in this concept, you can read it further, but I'll explain the basics of wisdom of crowds to you here. So Surowiecki uses this example. It's a really good example of the wisdom of crowds. Is the jelly bean jar guessing contest, where there's like a jar of jelly beans and you have to guess how many jelly beans are in it. If 100 people were to write down their guesses and then take those 100 guesses and add them together and then divide them by 100, basically average, if they were to average those 100 guesses, the average of all of their guesses combined is going to be closer to the true number of jelly beans in that jar than any one person's guess. So most people are going to be pretty wrong. But when you put all of their guesses together and you find the average, it's very accurate. It's going to be more accurate than the individual guesses. So you end up with a better guess when you let people guess on their own and then you average it. So this is not collaborative because people aren't getting together and talking about, oh, I think there's 10. No, it looks like there's 14. You know, they each make their own guess individually. And this is actually an important aspect of the wisdom of crowds. The guessers aren't working together, and that's good. That's what makes the wisdom of crowds smarter and more accurate, is that people aren't working together, because when people work together on problems like this, they tend to fall victim to what's called groupthink. So the loudest voice becomes the answer, right? The person who refuses to give up on their suggestion, the person who thinks there's 84 jelly beans and just will not listen to anyone else, everyone else ends up just kind of going, God, fine, you know, there's 84. And people who have good guesses don't speak up because they don't have the loud personalities. So groupthink is when everyone sort of comes together and people feel like they can't contribute, and so the loudest voices take over and everyone else starts to sort of believe the loudest voices. So you don't want that. That's not how wisdom of crowds comes about. Wisdom of crowds comes specifically because these people aren't working together. They're not working as a group. They're each doing their own thing, and then we're averaging their responses. And their responses, when averaged, are more accurate than each person guessing alone or than asking everyone to come up with one answer. And so wisdom of crowds, this idea that crowds can be very smart when each person provides a guess or a suggestion for a decision. When you average it out, the answer is smarter. The decision is smarter. Crowdsourcing is a term you may be familiar with, and this is a term that's used to describe just implementing the wisdom of the crowd. So wisdom of crowds refers to the fact that when people work individually and then their work is put together, it's smarter and better. Crowdsourcing is the action of creating that system, of asking people to give their guesses, of asking people to suggest a decision. And this term was created by Wired editors in 2005, and the crowdsourcing was really famously used in 2007 to try and find a missing scientist, a computer scientist, Jim Gray. He was sailing by himself off the coast of San Francisco, and he was never heard from again. Like, nothing specific happened. It wasn't that there was a big storm or, he made a distress call. He just never came back. And a blog was created that featured data of his last known whereabouts. So data about where he was, data from his cell phone, which had been connecting to cell towers. You can pull up cell phone records and see what cell towers a phone connected to, and it'll give you a basic sense of where the phone was and therefore the person, which, complete side note, those of you who have Android devices, if you use Google Maps, you know the traffic information where you see if traffic is bad and it's marked by green, yellow, or red, that's crowdsourced. What Google does is it takes information from phones. So while you're sitting in traffic and you have your phone on you, if your phone's not moving, that tells Google that wherever you are on the street should be red, that traffic is bad. If your phone is consistently traveling, at 60 miles per hour and you're on a highway, that tells Google that the highway is clear and that traffic is normal, and that makes it green. So that's actually a crowdsourced system that you're using every time you use Google Maps. So anyway, so people are trying to find this computer scientist. They're pulling data from cell phone towers. They're pulling data from the navigational system on his boat, which also had been making pings, and trying to get a sense of where he was. And everyone's sort of giving their own guess. And the idea with the wisdom of crowds is that when all these people give their guess, when sailors come in and look at the last known position of the computer scientist and say, well, I know a lot about this area. I've sailed it before. Here's my guess. And then data specialists who are familiar with and study cell phone technology can look at the information from cell phone towers and say, well, most likely this is the location where that cell phone was. When all those different specialists come together and give their guess, the idea of the wisdom of the crowds is that if we average that, we're going to be more accurate in determining where he is. This same concept was used to try and find the Malaysian airliner that went missing in 2014, earlier this year. I think it was MH350. Same concepts were used. And on top of that, in both of these cases, another form of crowdsourcing was used, which was satellite technology. So satellite companies photographed the areas where the computer scientists went missing and then later where the plane went missing. And people at home on their computers who had some free time could log in to different sites, and they would be presented with just a snippet of that satellite image, and they would just look for anything. So I actually did this when the Malaysian airliner went missing. You sign in and you get a square, and it's a satellite image, and you zoom in and you look, and if you see anything that looks like wreckage or an oil slick or something fishy, you tag it, and that alerts the system that other people need to look at it and see if something is there. Unfortunately, neither Gray nor the Malaysian airliner were found through these methods, but they were really sort of seminal examples of crowdsourcing and of trying to harvest the wisdom of the crowd to solve a problem or to find an accurate piece of information about something. So both really interesting examples of crowdsourcing, trying to understand the wisdom that a crowd would have that might help solve a problem. That's everything that I want to talk about. If you have any questions this week, feel free to send them my way. I'd be glad to answer them. But other than that, I look forward to seeing what you have for me for your assignments this week.